In this video, you will understand why helicopter designs vary so much. Like one rotor on top of another, one in front and another in back, crane helicopters and helicopters with propellers. Are you going to understand what the criteria are during the design process to choose one type of helicopter or another? Hello there, Science Junkie. I'm Sergio Hidalgo, and this video, as you might imagine, is going to be the most interesting one in the series I've made about helicopters. Because we're going to put everything we've learned into practice so we can understand what makes these kinds of strange designs so interesting compared to conventional ones. Without wasting any more time, let's get to it. I'm sure the first strange helicopters you think of are the ones with two rotors. Here's something to consider. Why would you use two rotors, like in the photos I'm showing you? Most helicopters with two rotors share a common trait. They're very large and heavy. For example, let's compare the Bell utility helicopter, the classic Vietnam War helicopter, from the movies and all that, with the Russian Kamov K-50. The first one has only one main rotor, while the second one has two rotors. If we look into the technical data to really understand the difference, we can see that the maximum takeoff weight for both is completely different. The utility helicopter, one can take off with up to 4,000 kilos, while the Kamov can handle just over 10,000. Wild, right? That's over twice as much. So we can say that generally you'll want to have two rotors when you need to lift a lot of weight. To illustrate, imagine designing a helicopter resembling the utility helicopter, one but capable of carrying much more weight. The first thing we would do is increase the size of the blades, increase their diameter. But of course, as we saw in the first video of this series, which by the way, I'll leave in the corner and also put the link in the description, there comes a certain point when shock waves appear at the tip of the blades. Larger blades require the rotor to spin more slowly to prevent shock waves. If the rotor spins more slowly, it might not generate enough lift. Therefore, here we see where the limit is. The bigger the blade is, the more centripetal force it will have to withstand so it doesn't come apart. And that's why if we look at the diameter of the blades of these two helicopters, it's more or less the same, around 15 meters. So if we wanted to redesign the utility helicopter, one to carry more weight directly, couldn't we just increase the diameter of the blades? So what we would have to do is put two rotors. Here it's important to make several things clear. The first is that this configuration of rotors, one on top of the other, is known as coaxial because they share the same axis. And also, each one spins in a different direction. That way, you don't need to have a tail rotor, because as we also discussed in the first video, tail rotors in helicopters are necessary to counteract the torque generated by the main rotor. But if you have two rotors, one spinning in one direction and the other spinning in the opposite direction, they counteract each other. And this, in turn, has another advantage because when we use the tail rotor, a part of the engine's power was directed to the tail. And that isn't generating any lift force to keep the helicopter flying, is it? It's simply a part of the fuel energy that you're using to counteract the torque. But when we use two rotors, both generate lift force. In other words, all the energy, so to speak, is focused on lifting the helicopter. It's also important to know that adding two rotors generally doesn't double a helicopter's lift force, because the lower rotor gets air that's already very disturbed by the upper rotor. And this is one of the reasons why another type of helicopter design was developed. For example, the Chinook, or Chinook, however you want to call it, which has one rotor in the front and another rotor in the back. Here, air from the front rotor rarely interferes with air from the other rotor, at least while the helicopter is hovering. Once the helicopter starts moving, as I already mentioned in the video series, there are more things to consider with helicopters in motion. But anyway, just so you understand the essence, of course, in this type of helicopter, like the Chinook, the two rotors also spin in opposite directions to counteract the torque. Of course, this isn't the only advantage that these types of designs give you, since they also provide great maneuverability when dropping troops in the middle of the mountains, or picking them up, since you can simply rest the rear part on a ledge and the aircraft doesn't need to land completely. This would be difficult with a conventional design, but tandem rotor helicopters have a big advantage. And also, let's take this opportunity to answer the question I asked in the previous video, since generally helicopters with two rotors can fly faster than conventional helicopters. As I mentioned in the first video, this happens when a helicopter moves forward. The part of the rotor that moves against the wind will generate more lift than the part that moves backward if you have two rotors spinning in opposite directions. The lift increase from one rotor on one side of the helicopter is balanced by the other rotor increasing lift on the opposite side. And the first person who was able to answer this question correctly was Andres Jimenez, who said that the fastest helicopter was number 2 because it's an axial helicopter. What helps with the circle of inversion is actually not exclusively because of the circle of inversion. Anyway, he was the first to say it correctly. But of course, these kinds of designs also have incredible complexity. For example, coaxial helicopters. You have to make a cyclic plate, one on top of the other, and on top of that, they have to be on the same axis. It's honestly insane. I don't even want to imagine how difficult it can get. Also, you have to make sure that both rotors don't collide under any circumstances, because of course if they do, you would have a very, very serious accident. That's why a lot of vibration analyses are done, how much the blades deflect, and so on. And make sure that they don't hit each other. For example, in the Chinook, there's a part where both blades pass through the same spot, so the synchronization has to be incredible. But with the Cummins K1200, that's an extreme case. When I first saw this helicopter, I thought it was fake. But is this type really as plausible as others? You just have to make sure the synchronization is perfect, and that way the blades won't collide. Aside from this, there are other unusual helicopters, such as crane helicopters. If you look closely, these are literally flying beams that are prepared. They're designed to carry a lot of weight and be able to transport it. The idea is to place all the weight in the helicopter's opening. For example, if you're transporting metal, trees, or other items, you can place them in that part of the helicopter. Hollow, so the helicopter's center of gravity is central, which would help you. But really? The complexity that has to appear when flying, with the center of gravity in one place and the next day with the center of gravity in a completely different place. It's absolute madness. For example, if you're going to transport water, like the typical helicopters that put out fires and carry water bags, that makes the center of gravity drop a lot. We also have designs that are on the edge of being considered helicopters or not, like this design from Sikorsky, for example. We've already explained it on the channel. Helicopters and airplanes are mainly different because of one thing, and that's in airplanes. The system that provides thrust is completely separate from the system that generates lift, which are the wings. In a helicopter, the rotor serves the same function, generating both lift and thrust by adjusting its orientation. But these machines no longer fit this definition since they have propellers that generate thrust while the rotor generates lift. This helicopter is the world's fastest, reportedly reaching nearly 500 kilometers per hour according to Google. Let's use this helicopter as a summary of everything I've said. Because the lift you would need to achieve with a large rotor, you can also achieve with two small rotors. So what this does is, first, it lets you fly much faster before shock waves are generated at the tip of the blade, and second, it allows you to make the rotor. Both rotors spin more slowly. This also delays the moment when shock waves appear. I'm also convinced they're using optimized airfoil profiles at the blade tips to prevent shock waves. Since you have a propulsion system, you don't have to tilt the rotors. And do you remember the previous videos? We said that when you tilt the rotors, the lift force decreases. However, as I said, if you're not tilting them, the lift force remains constant. And meanwhile, with your propulsion system, you can generate a lot of thrust. Anyone discussing designs like the Sikorsky I mentioned also talks about the Eurocopter X3. Well, this one is even worse because it has small wings that generate lift at high speeds. So it's not just that the thrust doesn't come from the rotor, but since it has wings, not even all the lift comes from the rotor anymore. Like I said, a lot of people don't even consider this kind of design a helicopter anymore, while others do. Honestly, I don't even know what to think. It's just crazy. And finally, I wanted to mention this tail design on helicopters that have it, kind of twisted like that. Do you know why that is? I won't say. I want you to tell me. That's the question for the next video. What is the reason why the tail is twisted on these helicopters? I hope you enjoyed this video, that you learned a lot about the world of helicopters, which, as you already know, is magical. We'll keep discussing this on the channel. If you enjoyed the video, like and subscribe. And as always, you know, science lead. Well, and I wanted to tell you that we're really putting a lot of effort into a Discord server I've created. I'll put it in the description for anyone interested to join. Please read the instructions, they're important. And another thing, I want to remind those of you who support the channel the most, who are always there for me in the comments, that you can contribute to what I do on Patreon. It's just for $1 a month, because $1 from several people ends up being a significant amount. I say this because, as you know, I'm very committed to the channel. I'm uploading videos despite being busy with exams and staying active. But anyway, if $1 a month still seems like too much because you're young or whatever, just remember that watching the ads also helps my content a lot. See you next week, and as always, science rules.